All right, I wanted to go over a few things for Lab 6. So one of these boxes, you should have written some observations. And then the other one, okay, down here in blank 1, you're going to write the chemical equation for the combustion of magnesium. So the book should help you get through this, but I just want to make sure that you're doing one correctly. So if you have magnesium, it tells you that it reacts with oxygen gas. And remember, oxygen gas comes as a pair. So we always have, if we have oxygen gas, we're talking about two oxygen atoms together. So oxygen gas is O2. And then this reacts to form magnesium oxide. So I know magnesium always forms a 2+ charge. And oxygen always forms a 2- charge. So I just need one of each of these. So that's my formula, my balanced formula. Now I have my chemical equation. I also need to write the phase. So this started as a solid, oxygen started as a gas, and then magnesium oxide at the end was that white powder. So that's a solid. And then I need to make sure that it's balanced. So I have two oxygens on the left, on the reactant side, so I need two oxygens on the product side. And so that also makes it so that I need a 2 in front of the magnesium. So then this would be my answer for blank 1. I have my phases, and I have a balanced chemical equation, and I've written the correct formula for magnesium oxide. The next thing that I wanted to look at with you is a single replacement reaction. So we're looking at table 6.3. We have a single replacement reaction. So when I'm looking at this first reaction, I have AgNO3 and copper. So again, the lab book helps us understand what's going on, or I will show you what's going on. So we have AgNO3. That was a liquid, but it was an ion that's dissolved in water. So I'm going to put, this is the aqueous phase. So remember, AQ is aqueous, and that's where we have an ion or something else dissolved in water. Okay. So something dissolved in water is aqueous, and most of the compounds that we're looking at today will be an ionic compound dissolved in water. So AgNO3 is aqueous, and we added copper, which is a solid metal. And then this is where we get the single replacement reaction. So we had copper solid, and we had silver nitrate. Well, now silver is going to be the solid. So if you saw a silver precipitate, that was silver metal precipitating out. So silver. And copper is going to gain the polyatomic ion nitrate. So we get silver metal, and we get copper nitrate. And the lab book tells us that we get copper NO3 too. We get copper nitrate, but copper is a 2+ charge. And I know that because I know that NO3 is a minus charge, and there's 2 of them. And this formula came from the lab book. And so if I have 2 NO3 minuses, the charge on copper to balance these 2 minus charges has to be a 2+ charge. So that's how I can figure that out. All right, so now we just need to make sure that everything's balanced. So on this side, I have 2 nitrates on the product side. So on the reactant side, I need 2 nitrates, and that changes my silver to be 2, so I need 2 silvers over here. And now it's balanced. And I have the phases. Oh, I need this one. This one is aqueous. So now I have the phases of all of my compounds, and I have a balanced chemical reaction. So this is what you're going to put in blank 1. So down here, it says blank 1. This is the molecular reaction, the molecular equation. Okay, blank 2 says total ionic. So we are going to break everything into its ions. So if it's aqueous, then it's going to change into an ion. If it's solid, it stays as a solid. So I'm just looking up here, and I know silver always forms a +1 charge. So I have 2 Ag plus charges, and I'm going to break this into its ions because it's in aqueous. It's in the aqueous phase. So I know I have 2 silver ions, and then I have this nitrate ion. So I have 2 nitrate ions plus 2 NO3 minus. I also have this copper that can't break into an ion, so we're just gonna let it hang out. And then silver is a solid. I can't break a solid into its ions, so we have Ag solid. So remember, if it's a solid metal, it's a 0 charge metal. All right, and then we also have copper. We talked about copper is 2+ here. Oh, and all of these ions should be aqueous, so we should go back and label their phase. They are all in the aqueous phase. And then we also have 2 NO3 minuses. We have 2 of those. So this is our total ionic equation. We're just going to scoot this up a little bit. The third thing it asks for is the net ionic equation. So that's in blank 3. So what I have to do is I have to look at the left side and the right side. And if there's anything that shows up on the left side and the right side, I can cancel that out for the net ionic equation. So 2 nitrate ions show up on the left side and on the right side. So those will drop out of our equation, just kind of like in algebra. If we have something on both sides, we can get rid of it. So what I have is 2 Ag plus in the aqueous phase. We're going to drop out the nitrate, so I'm going to look at the copper. And that goes to silver plus, oops, we don't want the nitrate. I dropped out the wrong thing. We have copper 2+ aqueous. So what's happening here is NO3 is called our spectator ion. It doesn't really do anything. It's just a charge balance. It's just kind of spectating this reaction. So that's for the single replacement reaction where one of the metals gets the polyatomic ion and the other metal that was with the polyatomic ion precipitates as a solid. Okay, the last one that I want to go over is the double replacement reactions in table 6.4. So in this part, we should have ended up with 4 things that got cloudy or formed solids. So 4 of these boxes should have formed solids. And then I'm going to write a chemical equation for these. I'm going to write 4 chemical equations over in these blanks. So kind of the same thing we were doing. We have 3 blanks for 4 equations. That gives us 12 chemical equations. So I'm pretty sure that all 3 of these gave us solids. And then one of the other ones did. I think it was this one should have given us a solid, and then all 3 of these. So I'm going to pick one. I'm going to pick this reaction number 3. We're going to do this one together. So double replacement. So this is where, so we have iron, here I have iron nitrate. This is iron 3 nitrate, and I have sodium hydroxide. These were both aqueous in the aqueous phase. And then when I reacted them together, this is a double replacement, and it talks about this in the instructions in the book. So you can go back and look at that. Okay, I'm going to scoot this over my table. So what I'm going to end up with is the metal. Both metals switch polyatomic ions. So iron is with nitrate, sodium is with hydroxide. The product will be iron ends up with hydroxide, and sodium ends up with nitrate. And so then I need to make sure that my chemical reactions are balanced. So I know here iron is going to be 3+. I know that because there are 3 NO3s, and NO3 nitrate has a -1 charge. And I have 3 of them, so I have 3 minus charges, so iron must be a +3 to balance that negative charge. So over here, iron didn't change charges, it's still 3+. So and hydroxide is a minus charge. Those are, we talked about those earlier. We should memorize our polyatomic ions. When we crisscross these, we end up with, we need 3 hydroxides for 1 iron. And then we don't write the formula, or we don't write the charges in the formula. So we have iron hydroxide. And we also have sodium hydroxide. Sodium always forms +1. Nitrate always forms -1. So we just need one of each of those. Okay, so these two started aqueous in the aqueous phase, but we don't know, one of these is our solid that formed. So if I go back to the table, I can look and see, this is one of the starting materials. This is one of the starting materials that is soluble. So this can't be the solid. This one is aqueous. And so this must be our solid. So you're going to have to use that kind of reasoning to figure out which of the products is your solid. So again, if I look at this table, NaNO3 was one of my products, and that's one of the starting materials. So all of my starting materials are soluble. They're all aqueous. So they are not going to be one of the products. They can't be one of these products. That is a solid. So then we've got our equation. Again, we have a double replacement because our metals switch polyatomic ions. And then we need to do the same thing. So this was our first step. Oh, we need to balance it. We have iron, 1 iron. We have 3 nitrates here. So we need 3 nitrates here. And that gives me 3 sodiums. So I need 3 sodiums here. We only have 1 iron. We only have 1 iron. So everything else is balanced. So hydroxides, we've got 3. We've got 3. So now it's balanced. Now, so that was the first blank. This is the total ionic. This is the molecular. Blank 1. And the second thing we need to do, so this was molecular. The second one is the total ionic equation. So we need to just break down all of these into their ions. So we know that iron is 3+ here, and that's in the aqueous phase. And then we have 3 nitrates, and that's also in the aqueous phase. And then here we have 3 sodiums, 3 Na+, that's just right here. Sodium is always a +1 charge. Plus hydroxide, we have 3 of those. Those are always a minus charge, and again, these are both aqueous. So make sure you get your phases in there. I just keep forgetting them. All right, and then we go over here. If it's a solid, this one was a solid, we can't split it up. So FeOH3, solid. And then we have 3 Na+, and we have 3, this is aqueous, 3 NO3 minus aqueous. Okay, that's a little bit hard to read. So I'm just breaking, for the total ionic, I break everything into its ions. And then the third step is the net ionic equation. So again, I look at the total ionic equation and I see if it's on one side and it's on the other side, it can drop out. So I have 3 nitrates, and this one's the hard one to read. This 3 nitrates. And if I look back through, I have 3 sodiums and 3 sodiums. So all of those will drop out in the net ionic equation. So now I have iron 3 plus in the aqueous phase. That dropped out, that dropped out. I have 3 hydroxides in the aqueous phase. And so these both dropped out. I have iron 3 hydroxide as a solid. So this is my net ionic equation. This is what is actually doing the chemistry. The nitrate ions and the sodium ions are just spectator ions. They're just hanging out. So these ones are spectator ions. All right, so make sure for the rest of these 4, so we did this one together. Make sure for the rest of these blanks that you have 3, or excuse me, you have 4 different solids that you need to write these equations for. Don't forget to do your post-lab questions.